Hello everyone, welcome to this session. We'll see discussing compounds of metals. To find our previous video, we are discussing about the metal oxides. We saw their preparations. We later on discussed their properties, and we saw the various uses of the various metal oxides. So today, let's move on to the other part, where we'll be discussing about the metal hydroxides. So the metal hydroxides, we'll start discussing about the preparation of the hydroxides of some metals simply by direct and the indirect methods. So from there you can see that metal hydroxide metal hydroxides can be prepared by either two of the ways, which are the direct method and the indirect method. The metal hydroxides are electrovalent compounds composed of the metallic ions, which are positively charged, and the hydroxyl ions, which are negatively charged. Now, the nature of the hydroxides of the metals varies according to the position of the metal in the reactivity series, as shown below. Here is uh, list or this the reactivity series. The first three of them, the potassium, sodium, and the calcium, the hydroxides of these metals are soluble in water and they are alkalis. Basically, they are basic hydroxides which are soluble in water. Then there is magnesium, aluminum, zinc, iron, lead. All these, the hydroxides of these are insoluble in water, and copper. These are insoluble in water. They are also photeric, except the magnesium, iron, and the copper hydroxides. So from this, the reactivity is where we get the concept that we talked before. That is, the nature of the hydroxides of the metals, they vary according to their position in this reactivity series. So the nature of the magnesium will be totally different from the nature of the potassium, or the nature of the sodium will be totally different from the nature of the zinc or iron. Now, later on the activities is there are these three, these the mercury, silver, and the other, the hydroxides of these metals, they simply do not exist. So there are no hydroxides of these last three elements in the reactivity series. Of the clear? Now, the metal hydroxides, they can be prepared in the laboratory by two methods, mainly the direct method and the indirect method. Starting with the direct method, in this method, it involves such processes such as adding metals directly in water. The method is suitable for the preparation of these soluble hydroxides, which are the alkalis. As you can see here, the reaction, how it happens, sodium plus water is equal to sodium hydroxide plus hydrogen gas, potassium plus water is equal to potassium hydroxide plus water, calcium plus water is equal to calcium hydroxide plus water. So that's simply the main method in this direct method, whereby a metal is reacted with water. Indirect method, this method, it involves the preparation of the insoluble hydroxides, which by reacting with the aqueous solutions of sodium or potassium hydroxides with the aqueous salts of metals. These are the ones that are called the precipitation reactions. Only the ammonium hydroxide, potassium hydroxide, and the sodium hydroxide are those that are completely soluble in water. Calcium hydroxides, they simply that is sparingly soluble in water, as you can see in detail of 0.173 gram per 100 mils liter of 20 at 20 degrees. Now, all other hydroxides are soluble in water, and they can be obtained in this kind of a way. Now, as you can see, the reaction of how it happens, this how these hydroxides are obtained by the indirect method. Here are the reactions. You can pass through them as the example. Take an example. This uh, copper plus the hydroxide will lead to the copper hydroxide. The same goes to this iron sulfate plus potassium hydroxide will lead to iron hydroxide plus potassium sulfate. The same goes to all the other elements. So this is how hydroxides can be obtained indirectly. So that's all I have for this session. We've started discussing more about the hydroxides. We've seen that they can be prepared by either a direct method or the indirect method. So that's all for this video. In our next video, move on to the various properties of the hydroxides. I hope that's all clear, and thank you.